In part 2, we will talk about Bronco the skydiver, the acceleration. And the acceleration is going to look like this. He is going to start off accelerating at a negative 9.8 meters per second, and it will begin to curve toward the flat where he has no acceleration. So in this area he's accelerating downward, and his acceleration is lessening because of the wind resistance. And in this area he is going to accelerate no acceleration, that's terminal velocity. And then once again he's going to hit an area where his parachute opens, and so he is going to accelerate kind of drastically upward. And so this is going to slow him down, so this is an upward acceleration, which is going to counter his speed. And then as it balances out, he is going to have terminal velocity again, where he's not accelerating. So the hardest part of this whole drawing is what the forces are doing, and this is the last thing we have here, what the forces are doing. So what we're going to look at here is what the gravity is doing at first. So the gravity is the mass that is pulling him downward times negative 9.8 newtons per kilogram. And so this is a force that is pulling against his mass, and that gravity is not going to change. So we're going to make a nice straight line all the way across. It's not going to change. But then you have air resistance, and the air resistance starts at 0, and the air resistance is going to increase, and it will increase just like the way that just the same way that the acceleration changed, the air resistance is going to change, and that's what's causing the change in gravity. So our net result between the green and the red is going to be our net force. So our net force is going to be shown in orange here, and so our net force will be a combination of green and red. And so our net force starts off here, but then it levels off. So once again our net force is going to drop to 0 right there. So it was here green, all green, and then as we combine the green and the red, it drops to 0. So in this area, what's going to end up happening is, since our red, our wind resistance is going to level off right here, that's going to match our gravity. So since the wind resistance matches the gravity, then this area here is going to have no net force. The net forces cancels. The wind resistance is directly balancing with the gravity, and so that's why you have terminal velocity. We're going pretty fast, we're falling pretty fast, but we can't get any faster because the wind resistance is increased to this point where it's balanced. Now in this point, what's going to happen is your force of wind resistance is going to increase. And the reason your force of wind resistance increases is because you're going to pop your chute. So when you pop your chute, the force increases. Gravity doesn't change. Gravity is always the same, but the force is going to increase. So that is going to make a result that the net force also increases, and it increases up. So in this area we have this big bubble of braking. So that orange once again is the net force. Now once it levels off again, it's going to match, the downward force is going to be matched with the gravity. Excuse me, the gravity is the downward force, but that the air resistance will match with gravity, and then your resultant force, or your net force, will once again be 0. So the only difference is when we are leveled out at terminal velocity here. Oh, that's the wrong tool. If we level out at terminal velocity here, that's still the wrong tool. If we level out terminal velocity here, we're going pretty fast. Here, when we level out at terminal velocity, we're going much slower. So these points where it's flat are called terminal velocity. And the points where they have the curves here going up or down are where our velocity is changing.